Good day everyone. Our today's topic is about construction method and operation. But first, let us briefly describe or define what is construction method and operation. When we say construction method and operation, these are the procedures and techniques utilized during construction. Construction operations are generally classified according to their specialized fields. Ibig sabihin, construction method and operations ay yung mga activities na kailangan o nagko-contribute para sa delivery ng isang construction project. So, ating isa-isahin yung mga project construction method and operation na kinakailangan natin mula sa start hanggang sa completion ng isang construction project. Number 1 ay ating clearing the site. Number 2 is locating the structure. 3 is earth moving. 4 is stabilizing earth and structure. 5, setting foundation. Then, building superstructure. 7 is installing utilities. 8 is enclosing frame superstructures. And 9 is finishing the projects. Ang unang-una natin kailangan gawin is to clear the site. Clearing the site is the first task of site preparation. The site should be in a cleared and graded condition. Kailangan din natin i-consider yung mga site factors dahil mahalaga sila for those who are going to prepare and clear the site. Site factors such as the size of the site, the amount of natural growth or yung mga tanim na nasa loob ng site, man-made and natural obstacles, location ng site, ano yung mga nasa paligid pa ng site, yun yung mga site factors na kailangan natin i-consider. Site clearing practices to be used depend upon the problem found in the particular site. May mga site na kailangan i-remove yung trees, kailangan i-demolish yung old buildings na nandun, yung old underground structures, at yung iba pang obstacles na makaka-affect or makaka-delay ng construction process natin in the future. So, the contractor must know all about the site and about site clearing practices. May iba't iba tayong practices in clearing the site. So, ito yung mga most common site clearing practices. First one is demolishing. When we say demolishing, it means destroying. It could be through blasting or yung paggamit ng mga explosives or wrecking using bulldozers or wrecking balls. Yung other mechanical devices naman na pwede natin pang gamitin in wrecking is the crowbar, crawler tractor with a bulldozer, and crane with a wrecking ball. So, meron tayo ditong pictures about demolishing. This one is a picture of using blasting. This one is the crowbar, which is included in the other mechanical devices used in wrecking. Ito naman yung ating crawler tractor with a bulldozer. Then this one is the crane with a wrecking ball. This one is the wrecking ball. Meron namang mga gamit pa sa site na kailangan natin i-demolish na pwede pang mapakinabangan or pwede pang magamit in the future. So, yun ang mga kailangan natin i-salvage. Salvaging is saving things from being demolished or destroyed. This can be done by tearing down, taking apart, or removing the wanted material from the site. Example ng mga bagay na pwedeng i-salvage sa isang old na building ay ang mga electrical switchboards, plumbing fixtures, katulad ng bathtubs, mga sinks, pwede rin yung mga doors and windows. Our third common practice when it comes to clearing the site is cutting. In wooden areas, cutting means bringing down timber by using axes, explosive, or saws. Cutting can also be done with torch to cut through the pieces of metal. This cutting through the use of torch ay ginagamit natin para sa mga old steel towers or bridges. Yan ang ginagamit para sila ay makat. Meron din naman tayong iba pang special equipment na ginagamit for cutting. Example is the crawler tractors with bulldozers. These are used to push trees up to 18 inches to 20 inches in diameter. Kapag di naman kalakihan yung tree na kailangan natin i-cut, we can use the two crawler tractors with a heavy steel cable connecting the two. Next, we have burning. When the wood cannot be used or the vegetation has to be cleared, one of the best ways para ma-clear yung site is through burning. Burning is done by setting a fire under controlled conditions. By using special fuels, vegetation, even, and green can be set on fire. So, after masunog nung area, saka pa lang i-bulldozer to clean up the site. Next, we have earth moving. Ito yung kadalasang ginagamit para mag-clear ng sites para sa mga construction works. It can be a major part of construction work on heavy construction projects. It is the process of moving soil or rock from one location to another and processing it so that it meets construction requirements of location, elevation, density, moisture, content, and so on. Under earth moving, we have different processes involved. The first one is excavating, which is digging, this one. Then after we excavate, the materials are loaded or we undergo loading. We load it into dump trucks commonly. Then next is hauling, which means the activity of transporting goods by truck. And then after we haul it, next one is placing. Placing is the dumping and spreading of the material. Then next we have compacting, which we know has different types of compacting. Then next we have grading. Grading is the act of ensuring a level base or a specific slope. Then after that, we are going to have finishing. The last practice that we have here is disposing, which means removing from the site materials that are not wanted. It may be done by burying, burning, and holding away. More than one of the practices that we mentioned earlier are used in the actual preparing and clearing of one site. It can be a combination of, for example, demolishing and salvaging, or burning and cutting, and so on. Sometimes there are also special problems when it comes to a construction project. For example, to build a dam, the flow of the river must be changed. Paano naman kung kailangan nating mag-construct ng tulay? Nadadaan siya sa dagat. So, dito pumapasok yung caissons and cofferdams. Caissons are large tubes which are placed through water to solid ground, while cofferdams are a series of cells or units which sit on the bottom and are filled with soil and rock. Here we have illustrations of both caisson and cofferdams. So, let's begin with caisson, this one and this one. They are watertight structures that can be lowered into the water while preserving dry environment inside. So, kapag nailapag na siya dun sa tubig, saka pala magdidig yung mga workers in order to reach a solid surface na dun magre-restapan yung caisson. Next one is the cofferdam. Yung cofferdam naman, tinatayo siya dun sa body of water. Then, pagkatapos niya maitayo, saka ipapump out yung water para magkaroon ng dry environment dito kung saan pwede magtrabaho yung mga workers. Ang isa pa sa pinagkaiba ng dalawa is caissons is more permanent than cofferdams. Cofferdams ay temporary. Yung caissons is much permanent. So, in actual, cofferdams is just like this. After we clear the site, we are now going to proceed with the locating of the structure. And to do this, we need a surveyor who can take dimensions from a set of plans and mark on site. With the surveying equipment, the surveyor shows the construction workers the exact location and size of the structure that they are going to build. The workers are then able to put materials in the right place to construct a building. In locating the structure, we are going to use the principles of surveying. We have surveying for highways and surveying for buildings. First, we are going to discuss surveying for highways. The first and most important part of laying out a highway is to find the correct direction. The plans show the exact location of the highway to be built in relation to these landmarks or features. The surveyor does this by finding existing highways, trees, survey stakes already set, and other landmarks on the plan. In surveying, we need to determine the horizontal and vertical measurements. In determining the horizontal measurements, the surveyor, along with the landmarks or the features that he has previously determined, he uses transit and measuring tape to find the center line of the proposed highway. Then, stakes are set along the whole center line about 50 inches to 100 inches apart. After the stakes are set along the whole center line, we can now determine the control points. These points are the most important along the center line. It usually shows where the two lines cross or where the center line turns, which are well marked with flags and stakes to keep construction equipment from running over or bumping them. After the center line has been found out, the surveyor measures horizontally from it, both sides, and finds the edges of the pavement. And then these measurements and all the measurements are put into a notebook for future use. With this, the horizontal measurements needed for earthwork are then complete. Now that we have determined the horizontal measurements, vertical measurements must then be made. If in horizontal measurements we have the control points, here in vertical measurements we have the benchmarks. Benchmarks are points of known elevation or height above the sea level. The location of several benchmarks is shown on the plan. The surveyor uses his level and rod to find the height of the ground at each center line stakes. By comparing the real elevations with those shown on the drawings, the surveyor can now find how much cut or fill is needed to build according to the plans. So what do we mean by cut? In this context, cut means the amount of earth which must be cut away and removed to get the right elevation or height, while the fill in this context means the earth which must be filled in to get the right height. Then, the surveyor marks the amount of cut or fill needed on each center line stake. After this, the surveyor then marks the amount of cut or fill on the stakes at each edge of the proposed pavement. The cut or fill should slope from these stakes to some point on the ground. Ibig sabihin, maglalagay tayo ng stakes kung saan magkakaroon ng slope yung ating cut or fill. At dahil nga naglagay tayo ng stakes kung saan slope, meron tayong tinatawag na slope stakes. Slope stakes show the slope of the ground to be constructed. When the cut, fill, and other earthwork is done, the surveyor must put up new stakes for the workers to follow while they are constructing the roadbed. Dito natin gagamitin yung mga nakuha nating control points at magsaset din tayo ng mga stakes on each side of the pavement. Yung mga ilalagay nating stakes ay kailangan 25 to 50 inches apart and 2 inches outside the edge of the proposed pavement. The top of the stakes are set at the height that the finished pavement will be. Ibig sabihin, yung top ng ating stakes, yun ang magiging mismong level ng pavement. At ngayon na naset na nating stakes, yung mga workers natin, sila naman ang gagawa. Susundan nila yung mga stakes na nilay ng surveyor sa paglagay ng pavement. Ito naman yung sa surveying for buildings. Building plans generally show where the building will be in relation to the property line or some other feature. After the surveyor has marked where the structure is to be on site, he uses these markings to set control points. Control points are the points from which to measure both horizontal and vertical distances. Control points are put any place where they will be safe from the construction equipment. The actual layout of the building is done by using batter boards. Mga batter boards ay may sukat na 2 inches by 4 inches at nagsisilbi sila bilang stakes driven part way on into the ground. Later, we're going to show an illustration of the batter boards. We have here an illustration. These ones are the stakes, and on the stakes, batter boards are attached. The batter boards are constructed beyond the real line where the wall will be constructed para hindi magbubump in sa kanila yung mga construction equipments kapag ginagamit. Then to determine the real wall line, we can use strings which is fastened on the edge of the batter boards by using nails. Then these intersections are the corners of the walls. So aside from strings, we can also use sockets in laying out the line where the wall will be constructed. The surveyor does this for each wall until the building is located. Pwede din tayong mag-mark sa butterboards ng iba pang measurements or para sa ibang purpose katulad ng wall line for the foundation or columns. Sometimes separate butterboards are constructed to mark each line. Butterboard and the marks on them must always be clearly tilted to avoid confusing one butterboard mark for another. After establishing the horizontal measurements, the vertical measurements are also needed. Butterboards are usually set with the top board at a known elevation above the ground. A plumb bob, this one, is then hung from the wire, which is stretched between the butterboards. Vertical measurements can be made along the plumb line. This one is the plumb line. The surveyor checks if the correct locations are maintained many times during construction, especially on multi-story buildings where it is important that each floor to be on the right height. During the construction of large building, the surveyor looks to his transit to make sure that correct locations are maintained, uses the level and the rod to take vertical dimensions, and make sure na yung mga measurements sa plano ay tama dun sa actual building. So, mahalaga talaga na chine-check yung mga measurements kung siya ay tama, especially on multi-story buildings because pag nagkaroon tayo ng discrepancy dun sa baba, magpa-pile up yung discrepancy hanggang dun sa taas, especially if it's maraming floor. So, kapag nandun tayo sa site, minsan hindi natin ma-notice yung discrepancy, pero pag tayo lumayo, eventually, makikita natin na nag-slant na or nag-tilt yung mismong structure. Checking is also done by the surveyor to see how much the structure has settled during or after the construction. Concrete dams, bridges, and other structures are laid out in much the same way as that described for buildings. Often, surveying records are kept so that they can be used to check how much the project has settled or tilted. Our next project construction methods and operations is earth moving. From the word itself, earth and moving, it's basically about moving soil or rock. Moving earth, both soil and rock, has always been important to man. Siyempre, yung mga early man, they are limited when it comes to earth moving because they highly rely on physical strength. Now, we have huge pieces of machinery for earth moving. So, there's a big difference ng capabilities ng tao for earth moving now compared to the early times. There are many kinds of earth moving equipments. Mga types na nagre-range sa mga small farm tractors, na may mga attachments, mga large shovels, and other equipments. Mga equipment na ito is very much expensive at mahirap i-operate at i-maintain. So, ang iba pa sa kanila is very specialized. The contractor in many cases will have only some pieces ng mga basic equipment na meron para sa earth moving. When the job calls for special machines, the contractor goes to the subcontractor or leasing or rental agency who has them. Charges for rented machines are based upon the time the equipment is worked and how much it costs to bring the unit to the site and to return it. At dahil ang ating mga earth-moving equipments is malalaki or very bulky, transporting these equipments must be considered. These earth-moving equipments can be self-propelled, that can be driven to the site. Yung others naman has to be hauled on the site on flatbed trailer trucks, and others may be towed to the site. Ang pagta-transport din itong ating mga earth-moving equipments ay maaari maging complicated. So, we have to consider the distance to the site, the access roads to the site, the height and width of the equipment, the speed of kind of wheels on the equipment, and the total weight of the equipment. So, aside from these factors or these considerations, we also have to consider the things to do with the road. This may include the utility lines, mga linya ng mga kuryente or linya ng mga communication services. And then the bridges, number of lanes of traffic and other things to do with the road. So, recently, meron tayong mga naging cases dito sa atin na sumasabit yung mga heavy equipment doon sa mga lines. So, that's one of the things that we must consider when transporting these equipments. After we have transported the equipment, we have to set it up. But before the equipment gets to the site, the contractor must decide how he will use the machinery. All the needed things on all the needed ramps, the mats, the assembly areas, and the parking aprons are made ready ahead of time. This is done so that once the equipment arrives, work is done very quickly. Next, we have excavating. Earth moving is usually done by excavating or digging of material in one area, then transferring it or moving it into another place where it is either piled up, spread out, or used as a fill material. Excavating is done first to reach a good base for the foundation, and second to build basements. Third is to make cuts to hilly land for travel routes, and to level and even ground. Here we have samples of machineries used in excavating. These are examples of big machines used for this work. We have backhoes, drag lines, trenches, shovels, and clamshells. We have 7 basic ways of excavating. First one is the bulk pit excavating. Bulk pit excavating is done through digging up a wide and deep area. Yung ating loose material ay tinatransport natin by truck from the site or being hauled. Access to this excavation is very limited. Example of bulk pit excavating is when a basement being dug for a downtown building, which is between 2 existing buildings. Next is the bulk wide area excavating, where the areas are wide but fairly shallow and there is an easy access to them. Unlike dun sa bulk pit excavating natin na yung access is very limited. The process is mainly of leveling or yung pagpapatag. Example naman nitong bulk wide area excavating is the grading for a highway or an airfield. Airfield is an area of land set aside for the takeoff, landing, and maintenance of an aircraft. So in this case, leveling yung pinakang ginagawa. Next is loose bulk excavating. In this type of excavating, material is not hauled away but is piled up into a new position. Wet clay is the type of matter that is moved. So example for this excavating is the moving of soil in making dikes in order to form a pond. Next, we have limited area vertical excavating, which is done mainly by digging vertically. The sides of the excavation may be braced or shored, or simply supported. The material is lifted up and over the sides of the excavation. Example for limited area vertical excavating is digging for a basement. The next, we have trenching. This is an excavation which is long and narrow, wide enough so that the conduits or the pipes and other underground materials can be placed into it. The spoil or the removed earth is piled up on the surface at the sides of the trench. It is used later to refill the trench. Next, we have dredging. This is the removal of soil or other materials from underwater. It is much the same as loose bulk excavating. Example for dredging is the practice we use for making harbors or rebuild channels which are deeper. Tunnel excavating or tunneling, which is not usually considered under the heading of general excavation because it is done completely underground. There are instances na ang mga material na kailangan natin i-excavate ay masyadong matigas or tough or dense. So we need to lose them before we have to excavate them. So these are the common techniques, which are blasting, breaking, scarifying, and ripping. Blasting is done mostly to rocks. We use explosives to break the rocks into pieces. Next is breaking. In here, we apply strong blows to tear up hard materials. Example of tools used in breaking is the air hammers. Then we have scarifying and ripping. What they have in common is much tough or dense material is loosened by running blades or teeth through it, like blowing or yung nag-aararo. These are the differences of scarifying and ripping. In scarifying, it is usually done in the upper 18 inches of a soil, while ripping is done by pulling one or two large teeth with a tractor to loosen the material down to the depths of 2 to 3 feet. It is used instead of blasting wherever ripping equipment can get into the area and where materials are not too hard. Now that the earth is readily workable or it has been loose, then we can now excavate it and then moved out away.
In earthworks, we also have transferring and disposing. Here we have spoil, which are the excavated materials which is transferred or moved from one place to another then disposed. They can be stored for use for the site or for possible sale and later use on other sites. It may be disposed of by using fill or top dressing. Sabihin, when it was used in filling, ginagamit siya para ma-level yung low spots. Samantalang kapag ginamit naman siya as top dressing, ginagamit siya sa isang site bilang isang thin coat over an area. Ini-spread siya dun sa. Often, some of the equipments is both used for transferring and disposing operations. Transferring liquid waste such as water from construction site takes different kinds of equipment and preparation. Ang isang common na problem na na-encounter when it comes to liquid waste ay kapag umulan. Kapag umulan, pwedeng mag-collapse yung walls at saka filling ng mga holes natin sa construction site. Pwede din naman yung mga equipment natin ay ma-stuck sa putik. To address this situation, pumping is a normal way to transfer water from the site. So, pumping is used kapag may mga unwanted water sa site. Portable sump pumps, which are operated by electrical or gasoline power, are easily lowered into the excavation. The water is pumped through the lengths of piping to another location away from the working area or directly into storm sewers. Our next construction method and operation is stabilizing earth and structure. Here we have to make sure that the excavation is ready for foundation, and this is called trimming. There are 4 major practices used for trimming and shaping the excavation bed and walls. We have cleaning and washing, grading, sloping, and treating. For cleaning and washing, here we remove mud from the base rock done by high pressure water or hosing. In grading, we make the bed walls of the excavation level and firm, cut away the high parts of the excavation and filling in uneven low spots. This grading may be done through the use of compacting, grouting, or filling the excavation with mortar, scaling or scraping, or filling or moving in the loose earth. In sloping, earth sides of the excavation are sloped to lower the chances of slides. It may be used where a large building is to be built or dam is to be built. Sloping is another way of trimming or shaping. Next is treating. In this we use freezing of the soil. May be used when the earth is full of water and hard to drain. This helps to stabilize the soil and makes the earth from falling in and control water in the ground. In stabilizing earthworks, we have 5 main ways, which are compacting, sheeting, bracing and shoring, and piling and coffer damming. In compacting, we compress or pack down the earth to make it firm. So we are familiar with this. Then sheeting, we form walls to keep earth out of the excavated area. Common sheeting materials are metal panels and wood planks or panels. Itong mga metal panels and wood plank panels natin ay ilalagay natin dun sa earthwork na sinusuportahan natin with the use of bracing or shoring to make it more stable. Then bracing and shoring, these are processes usually used with sheet glue. In piling, large concrete, steel, or wooden flakes are driven into the ground to give more stability to a structure. Dahil yung piling ay ini-improve niya yung load-bearing capacity ng lupa at saka para maiwasan yung uneven settlement ng structure. There are two kinds of piles, which are the friction piles and or point support piles. Yung friction piles, ginagamit niya yung friction na develop between the surface of the pile and the soil para i-support yung structure. Samantalang yung end or point support piles, na-support niya yung load by having the other end of the pile rest on a thin layer of rock or earth below the ground.
Foundations in buildings are a major part of a structure that serves as a base to the columns and walls from which the overall weight of the structure transmit. They then transfer the full load of the structure into the underlying soil. Foundations are usually made of a reinforced concrete material specifically designed according to its uses. To decide which foundation is best suited for your design, it is important for the structural engineer to differentiate each of the types of foundations. In structural engineering world, there are two common categories of foundations in building design, namely, shallow foundations and deep foundations. Shallow foundations normally range from 1 meter to 3 meters deep from the natural grade level. They are more economical than deep foundations, since lesser volume of excavation is required because shallow foundation normally rest in hard strata that are located just near the ground surface. Deep foundation. A deep foundation is a type of foundation which is placed at a greater depth below the ground surface and transfers structure loads to the earth at depth. The depth-to-width ratio of such a foundation is usually greater than 4:5. The construction process of a deep foundation is more complex and more expensive than shallow foundations. However, when dealing with poor soil conditions at shallow depth, large design loads, and site constraints, a deep foundation is likely to be the optimum solution. Parts of foundation. A foundation can be divided into three parts. 1. Bearing surface is a part of the earth on which the foundation rests. 2. Upright supports, such as wall and piers. Pier is a column designed to support a concentrated load. A member, usually in the form of a thickened section which forms an integral part of a wall, usually placed at intervals along the wall to provide lateral support or to support concentrated vertical walls. It is the upright support that rise above the footing to form the rest or the substructure. 3. The footing is the part of the foundation that supports the concrete slab, floor joists, or blocks. Footings are formed by filling an excavated ditch with concrete to ground level. The footing runs along the entire perimeter of the structure. Three kinds of footings that are often used. 1. Spread footing. 2. Raft or slab footing. 3. Pile cap footing. Spread footings. Spread footings are the simplest kind. They are used on bearing surfaces of rock or of soil that is packed solidly like hard clay. It is a pad which may be long and rather narrow to go under a wall, or it may be square or rectangular where it is to go under a pier or post. Raft or slab footing, where the soil of the bearing surface is soft or where there might be vibration due to an earthquake, a spread footing cannot be used. In such cases, a raft or slab footing may be used. A raft footing spreads the weight of the structure over a very large area. It is used only with small, lightweight structures where the bearing surface is too soft for a spread footing. The raft footing usually covers a larger area than that of the structure it supports. Pile cap footing. When the bearing surface is in marshy land, in sand, or underwater as in river, lake, or along the ocean, we must find a good bearing surface. Piles are driven down through the soft or wet soil until a strong supporting layer of hard clay or rock is reached. A footing, like a spread footing, is then built on top of the piles, which is called a pile cap. Different structures need different kinds of bearing surfaces, depending upon how heavy the structures are. The designer must decide what kind of bearing surface will support the weight of each structure. Today, concrete is the most common material used for footings. Sometimes only concrete is used, but it can be made stronger by burying steel rods in it for reinforcements. Most footings are horizontal. Sometimes, footings are vertical. Driven pilings are an example of vertical footings. Many times vertical piers or walls are added to horizontal footings to build them up to grade level. Piers piles or foundation walls may be made of natural materials such as stone or wood. They also may be made of reinforced concrete or steel. How to lay foundations. If you're the project manager for your self-build or taking on the work yourself, it's critical to double-check all measurements for the building foundations and make sure everyone on site is working from the same plans to avoid costly mistakes that are difficult to rectify. 1. First, you will need a level datum point. If you are building an extension, this is usually the finished floor level or damp-proof course of the existing building. For new builds, this will be marked on the plan as a fixed point such as a manhole cover or a marker in the road or pavement. 2. Calculate how much material needs to be removed from the site to end up back at finished floor level once all the layers of flooring materials, insulation, concrete, screed, etc., have gone down. Time taken with a site level at this stage will make things easier later on when the digger may not be able to reach any areas that have not been dug deep enough. 3. Start marking out for the walls. Set up timber hurdles at the end of each wall, out of the way of where the digger will need to be. These carry the string lines that represent the wall faces of your building. Where space is limited, use corner pins instead and set up the hurdles after the concrete is in. 4. Begin lining up your footings by referring to your datum point. When it comes to extensions, never assume an existing building is square. Pick the side you need to be square to and set up a line, then square off that line. 5. Once you have two lines set up at 90 degrees, all other measurements can be taken from this point, with all corners and junctions marked. A lot of digger drivers are quite happy for you to mark center of dig lines, but you may prefer to mark both sides of the trenches. 6. Now you are ready to start digging. Have your site level set to the depth you need to dig and check it often. Ultimately, it is down to the building control inspector to decide how far down you need to go. They will inspect at this stage and advise. 7. Once building control has visited, you are ready to pour the footings. You should place depth pegs in the trenches to show you how deep to fill, but you may find that marking the sides of the trenches with marker paint also works well, with a final once-over with the site level and a concrete rake to get them spot on. The more accurate you can be with your levels, the easier and cheaper the next stage will be. If your site is difficult to access, it may be worth considering a concrete pump. This can work out more cost-effective than a few bodies with barrows. The bearing surface is first prepared to support the footing. When the bearing surface has been prepared, the footing can be placed. Since most footings are made of concrete, let us see how they are made. Concrete footings are made in 6 steps. Forms or molds are set in place. Rod setters place steel reinforcement in the forms where it is needed. A mixer operator puts materials into a drum and mixes them to make concrete. Concrete laborers and cement finishers place the concrete in the form. The cement finishers compact the concrete in the form and finish the surface of the concrete. After the concrete has set, the laborers remove the formworks. Concrete is made of stone, sand, and water bound together with cement. When concrete has been freshly mixed and is still wet, we can handle it just as we would handle wet mud. Shortly after it has been mixed, it begins to set. It finally becomes as hard as stone. In order to get the shape of the slabs, footings, walls and piers that we need, we must shape the concrete. Concrete is shaped by placing it into the forms while it is still wet. The forms of the concrete are something like the molds into which gelatin is poured. When the gelatin is set, it can be dumped out of the mold. It then has the shape of the inside of the mold. When we are shaping concrete, we do not simply pour it into the form, mold. We do not dump it out after it has become hard. Concrete must be carefully placed in the form. Also, we remove the form, piece by piece, leaving the concrete in the shape of the form. Therefore, the form must be strong enough to keep the concrete from bulging from the weight of the wet concrete. Concrete foundation forms usually are made of wood. They also can be made of steel, or a combination of wood and steel. Wood is lighter in weight, easier to handle and less expensive than other materials. Also, it is easier to change the size and shape of wood by using hand tools unlike steel. Two kinds of wood or lumber used in building forms. Dimension lumber. This is called dimension lumber because we speak the size of the piece by its dimension. Plywood. This comes in large sheet 4 feet wide and 8 feet to 10 feet long. These sheets most commonly are 1/4, 1/2, 3/4, or 1 inch in thickness. They are used to cover the frame built of dimension lumber. Instead of plywood, we may use a kind of dimension lumber called planking, sheeting, or boards. These usually are 1 or 2 inches thick and may be of different widths from 4 inches to 12. Preparing the materials. The first step in building a forms is to prepare the materials. The lengths of the pieces of dimension lumber and the sizes of sheets of plywood that will be needed must be measured and cut. Form parts. 7 main parts of a wood foundation. Plates, studs, wailers, ties, braces or shores, stakes, facing. Forms for a slab foundation. Forms for large slabs or for smaller spread footings are assembled in the same way. If the slab or footing is less than a foot in thickness, we may need only boards or facing materials, some stakes, and some bracing lumber. If the slab is thick, we will need all, or almost all, of 7 parts of forms. Forms for a wall foundation. A wall almost has the 2 sides. Therefore, 2 facings are needed inside a wall form. Sometimes, the earth forms 1 facing. The line for one side of the wall is marked on the concrete footing. The panels are placed in position along that line. Wailers, in pairs, are nailed to the back of all the panels to keep them in line. Bracing and stakes then are put in to hold the wall in an upright position. After this one face of the form is in position, reinforcing steel is set. Forms for a pier foundation. Piers may be square, rectangular, or round. Piers that are to be square or rectangular are formed with 2 short sets of wall forms. E-forms may be built in place, or they may be prefabricated panels. When round pier is to be built, sections of metal or fiber tubes are used. These sections are assembled into what looks like a large piece of pipe. They are set in place on the footing and are plumbed so they stand straight. Then braces are used to hold them in position. Cover. One important reason for placing the reinforcing steel properly is to achieve the right amount of concrete cover, the amount of concrete between the reinforcing steel and the surface of the concrete member. Cover is the single most important factor in protecting reinforcing steel from corrosion. Cover is also necessary to assure that the steel bonds to the concrete well enough to develop its strength. The requirements for minimum cover are usually listed in the project specifications or shown on the drawings. Where not specified, the minimum cover for cast-in-place concrete is specified by the ACI 318 Building Code. Positioning. Placing reinforcement atop a layer of fresh concrete and then pouring more on top is not an acceptable method for positioning. You must use reinforcing bar supports, which are made of steel wire, precast concrete, or plastic. Chairs and supports are available in various heights to support specific reinforcing bar sizes and positions. In general, plastic accessories are less expensive than metal supports. Tolerances on placement. Although bars should be placed as close to the specified position as possible, there will always be a little bit of variation. The tolerances on rebar position, as defined by ACI 117. A tolerance, according to ACI 117, is the permitted variation from a given dimension, in other words, how far off the rebar actually is from what's shown in the drawings. So, for example, if the clear distance between the outside of a reinforcing bar and the face of a 6-inch wide concrete beam is specified to be 2 inches, the tolerance allows it to be no less than 1 5/8 inches. Here are some things to remember about placing rebar. Bar supports are not intended as support for construction equipment such as concrete pumps, buggies, or laser screeds. Spacing of bar supports depends upon the size of the reinforcing bar being supported. For example, for a one-way solid slab with number 5 temperature shrinkage bars, high chairs are used at 4 feet on center. For #4 bars, high chairs would be placed 3 feet on center. Placing reinforcement onto layers of fresh concrete or adjusting the position of bars or welded wire reinforcement during concrete placement should not be permitted. The ill-advised practice in slab construction of placing reinforcement on the subgrade and pulling it up during concrete placement is called hooking. Spacers for vertical concrete wall construction have traditionally been optional. Side form spacers include double-headed nails, precast concrete blocks, dobies, and proprietary all-plastic shapes. The ironworker, foreman, contractor, and inspector all have the responsibility to see that the reinforcing bars in concrete construction are properly placed. Deviation from specified location, in slabs and walls, other than stirrups and ties plus or minus 3 in. Stirrups, depth of beam in inches divided by 12. Ties, width of column in inches divided by 12. Preparing coarse aggregates. Gravel or crushed rock is used for coarse aggregate. Gravel is found in natural deposits on the Earth's surface. Crushed rock is manufactured by breaking rock into pieces into a rock crusher. Pieces of crushed rock have sharp edges and may shaped much like cubes. This is the best shape for aggregate. If the rock is too soft, it will crush into powder which cannot be used. Some kinds of break up into thin, flat pieces which also should not be used for concrete. Preparing fine aggregates. The sand that is used in concrete is called fine aggregate. Just as with coarse aggregate, fine aggregate has different sizes. It is graded to get the different sizes used in concrete. Generally, both the coarse aggregate and the fine aggregate are washed before being graded. Washing removes particles that are too small. Rock dust or clay often found in stone or sand would be examples of such particles. The prepared aggregate is stockpiled until it is needed. Preparing cement. The cement used in concrete is Portland cement. Portland cement is made from a certain kind of limestone that is found in deposits under Earth's surface. The limestone is quarried out of its solid deposit in pieces. Then it is crushed into a fine powder in a crusher. Some shale and clay is also crushed and mixed with the limestone in the right amounts. The mixture of limestone and clay is fed into a rotary kiln and heated at the temperature of 2700 F. During the process, it forms a porous mass called clinker. The clinker is taken from the kiln and ground to a powder. Then a small amount of gypsum, much like the lime used in masonry, is added to make the Portland cement. When the Portland cement is mixed with water, it forms a paste that becomes firm or sets in for about 2 hours. After the paste sets up, it slowly becomes much harder. The setting up and the hardening of cement paste is caused by the chemical reaction between the cement and the water. This is called hydration. Concrete may be mixed on the site, at a batching plant, or may even be mixed on the way to the construction site in a transit mix truck which has a large drum on it. The drum turns slowly during its trip from batching plant to the construction site to keep the concrete mixed. In unloading the concrete and placing it, every step must be carefully done to keep the heavy particles from separating from the rest of the mixture. Different methods: unloading and moving the concrete, placing and consolidating the concrete, leveling concrete, floating concrete, finishing. When the truck driver is ready to unload the concrete, he reverses the drum. This moves the concrete out of the gate that has been opened to let the concrete flow from the truck. The truck also carries a small chute. One end of this chute fits under the gate, and concrete flows into it. The chute slopes down from the gate to the ground. At the lower end of the chute there must be a container to hold the flowing concrete. Important factors in choosing transportation. There are many elements of transporting that need to be considered in order to ensure that a mix does not change its state as specified in the contract. The two key goals when transporting concrete from the mixing plant to the construction site are to prevent segregation and to not reduce the workability of the mix. This transportation process must be well thought out and organized efficiently. As a general rule of thumb, 30 to 60 minutes of transportation are acceptable on small jobs. At a central or portable ready-mix plant, concrete should be discharged from a truck mixer or agitator truck within 2 hours. If non-agitating transporting equipment is used, this time is reduced to 1 hour. All delays must be avoided in order to prevent honeycombing, or cold joints. Categories of transportation. There are many modes of transportation as shown below. Wheelbarrow or motorized buggy, truck mixer, bucket or steel skip, chute, belt conveyor, concrete pump, pneumatic placer. Placing and consolidating concrete. In locations where the concrete is to be thick, it is placed in the layer for about 12 inches deep. After each layer is placed into the form, it is worked with rod or shaken by vibrator to consolidate the concrete. A vibrator is a tube that is closed at the end, about 12 inches in length and 2 inches or 3 inches in width. A long hose containing a flexible shaft is fastened to the open end and put over into the wet concrete. A shaft in the hose is turned by a gasoline engine or an electric motor which causes the tube or vibrator head to shake. The vibration forces the concrete tightly against the form and get rid of air bubbles. Leveling concrete. When all of the concrete has been placed, the concrete surface should be at the same level as the top of the form. To level the concrete, we use a straight edge rested on screeds, guides of leveling the surface. The straight edge is a long piece of wood or metal. One end of the straight edge rests on the opposite side of the form. Concrete finishers push the board back and forth over the concrete until the surface is level with screeds or top of the form. When a slab is very large, one straight edge will be too short to reach one side of the form to the other. The additional screeds must be set in between the form faces. These screeds are pieces of lumber or steel that are set parallel with one face of the form inside the area where the concrete is to be placed. The top of all the screeds are at the same level. After the concrete in the slab has been placed and has been smoothed by this process, the concrete soon sets up. When the surface is stiff but not hard, the screeds inside the form are then removed from the concrete, and the grooves they make are patched. Floating concrete. After the concrete has stiffened, floating is done by the cement finisher. A tool called a wood float moves back and forth over the surface until it is level and no coarse aggregates can be seen. Floating the surface is done to be sure that there is only a smooth mixture of cement, sand, and water on the surface. No coarse particle should show. After the concrete has been floated, a final finish can be put on. Sometimes, a float finish is used as the final finish. Finishing. Usually a smooth finish like that found on a sidewalk is needed. A smooth finish is called a steel trowel finish. The smooth finisher makes it by moving a steel trowel back and forth over the surface. A troweled surface can also be made with a finishing machine. The finishing machine has an engine or motor that slowly turns a wheel which 3 or 4 steel trowels have been fastened. It can finish a large area in a short amount of time. Completing foundations. After the concrete has been placed in the forms and the visible surfaces finished, there are still several important steps for completing of the foundation, which is allowing the concrete to set, removing the forms, making sure that the concrete is properly cured, treating the surfaces which were covered by the forms, allowing the concrete to set. Concrete is set when it will retain or hold the shape given to it by its particular form. Concrete which is set is firm, but it is not hard or strong. The amount of time needed for concrete to set depends upon the kind and amount of concrete used and the temperature and humidity during that time is in its form. However, concrete will set in 12 to 24 hours. It usually takes a much longer period of time for concrete to become hard and strong. The time needed for the concrete to become hard and strong is called the curing time. Removing the forms. The process of removing the forms from around the concrete is called stripping the forms. The workman must not strip the forms until the concrete has properly set. In some cases, the concrete is allowed to cure before the forms are removed. Concrete which has set but has not cured is called green concrete. It is firm but not hard and strong. Treating the formed surface. Formed surfaces are those which touch the forms and can be seen only after the forms have been stripped. The first step that the concrete worker take in treating formed surfaces is patching holes caused by the form ties and any other defects which show in the concrete. The workers put a mixture of sand, Portland cement and water into holes and other chips which show after the forms have been removed. The final treatment depends on the location of the surface. If the surface will touch earth, it may be needed to be protected from moisture. Concrete is waterproof if a perfect job of placing and finishing is done. Usually, there are small defects which allow moisture to gradually seep through the concrete. Therefore, workmen waterproof the concrete by putting a layer of asphalt on the surface. Then men either brush or spray the asphalt onto the concrete. If a very durable or strong waterproofing is needed, the workers put on alternative layers of asphalt as needed. The workers put on alternate layers of asphalt and asphalt-saturated paper to build up a thick coating on the concrete surface. If the surface of the concrete will not be in contact with the moisture and will be exposed to view, like the surface of the piers which support an elevated highway, it is treated in a different way. The workman may treat the surface with a stone finish, a sack-rubbed finish, or a special coating. To apply a stone finish, the workers wet the concrete surface thoroughly with water and then rub a mixture of sand, Portland cement and water over the surface. Then the surface is ground with a flat stone until it is smooth and all blemishes are removed. The concrete finishers apply a sack-rubbed finish by wetting the concrete surface, rubbing a thin mixture of sand, Portland cement and water over the surface with a piece of burlap or sponge float, and the rubbing a dry mixture of sand and cement over the same surface. Then the finishers have completed the sack-rubbed treatment. The surface has its appearance of sandpaper, but all holes have been removed.
Ang i-report ko naman po ngayon ay building superstructure. The superstructure is built on top of the foundation or substructure. Towers such as those used for television, broadcasting, or for transmitting electricity are mostly superstructure. The design of a superstructure depends upon the purpose for which the superstructure will be used. The substructure supports both the weight of the superstructure and the traffic. Now, let's go to the kind of superstructure. Ang una dito is mass superstructure. These are made of large bodies of materials which generally cover large areas. Example of mass superstructures are earth or concrete dams and cast-in-place concrete retaining walls. Large monuments built of piled-up stone, such as the pyramids of Egypt or the Washington Monument. Mass superstructure may have very little or no open space inside the mass of materials. The next kind of superstructures are bearing wall superstructures. These are made of masonry or other materials and usually built as walls or walls and roofs. Bearing wall superstructure enclose a space. And ang last nating kind of superstructure is frame superstructures. These are those such as houses are built with a frame. The frame is like a skeleton. The parts serve the same purpose as do the bones in your body. Frame superstructure may be made of steel, reinforced concrete, or wood. The members of a frame are columns or posts with beams connecting one to another. Now, let's go to the building mass and masonry superstructures. Ang una nating mass construction materials are soil. Soil is very common and widely used construction material. It is available in large quantities and it is not too expensive. Soil is used to build earth dams and other types of earth embankments. It is used to shape our highways and waterways. Even before putting down the substructure of a roadway, soil is moved, placed, and graded to give the correct slope of the road. Using soil in mass construction usually involves some steps. Ang una dito is selecting good soil for the job. The next is excavating, hauling, spreading and mixing, and compacting. Ang next nating mass construction material are rock. Rock can be excavated in large blocks or pieces by quarrying. Quarrying means getting rock out of the earth. These pieces can be used for massive or very large superstructure. Sometimes, large pieces of quarried rock are needed where the shape of the block is not important. Breakwaters and jetties which slow up the erosion caused by ocean waves are superstructures made of irregular or odd-shaped blocks of stone piled loosely in a long heap. These blocks of stone can be quarried by drilling and blasting. Mass superstructure also may be built of cemented aggregates. Many kinds of aggregates and ways of cementing them are used for mass superstructure. Concrete is the most common kind of cemented aggregates. In primitive or early construction, mud and clay were held together by mixing them with straw, reeds, and brush. Now, let's go to the highway superstructure. The surface of airports and highways are a kind of mass superstructure. To build a concrete road, the earth along it is shaped to make a foundation. The soil is compacted or pressed down until it is fairly hard. A substructure or crushed rock or gravel is then placed as a foundation. On these foundation forms are set along both sides of the strip where concrete is to be placed. These forms are made of heavy steel sheets which are bent so that the top edges are rounded like the rails of a railroad track. They are secured or fastened to the foundation surface with long steel pins driven into the earth. Another kind of roadway surface is made with bituminous concrete. This is a kind of cemented aggregate using crushed stone as a coarse aggregate and a sand as a fine aggregate. Asphalt is used as a cementing agent instead of Portland cement. Asphalt is a black tar substance which can be found in pools or lakes on certain parts of the Earth's surface. It also can be manufactured from petroleum or from coal. Bituminous concrete is prepared in mixing plants much like those used for making concrete. The aggregates are weighed and moved into a mixer on a conveyor belt. The asphalt is melted and brought to the right temperature and thickness before it is poured over the aggregates in the mixing tank. When the bituminous concrete has been mixed, it is poured into dump trucks which take the mixture to the paving site. Bituminous concrete is usually placed in layers. The bottom layer has larger size of aggregates and the top layer is made up of either small aggregates or of fine aggregates. For this reason, steel forms may not be needed along the edges of the paving. The truckload of bituminous concrete is hauled to the site and dumped into a paver. The paver spreads the bituminous concrete over the prepared road foundation surface in an even layer. Steel-wheeled rollers follow the paver and compact the bituminous concrete while it is still warm. Rolling is continued until the bituminous concrete becomes a hardened mass with a smooth surface. Another material for bearing wall or masonry construction are bricks. Bricks are used for building many bearing wall superstructures. However, they are not used in a large mass as bricks were used in building the Tower Babel. In bearing wall, small bricks are now used and each brick is carefully placed in position by masons or bricklayers. Many kinds of stones of stone, solid concrete, and concrete blocks also are used to construct bearing walls. Most of the bricks used to build bearing walls are 8 inches long and 3 3/4 inches wide and 2 1/4 inches thick. There are 6 positions in which the bricklayer can place this brick in a wall, and each of these positions has a name. The positions of a brick are those the bricklayer would see looking at the front face of the wall. Ang unang position dito is the stretcher course. Yun yung if a brick is laid in a course in the flat position so that the 8 inches dimension is along the course is 2 1/4 high. The next is the solder. If you turn the brick on end so that the 8 inches dimension is pointing up and down. The next is the header. If the brick is turned so that the end shows with the 3 3/4 high along the course. The next is the rowlock. If the brick is then turned 90 degrees so that the 2 1/4 inches side lies along the course. The last two is the shiner and the sailor. The two other positions in which a brick may be placed in a wall are not often used. Erecting steel frames. Steel frames are generally erected at the construction site one piece at a time. Each piece of steel must be a proper size, and this preparing of each piece is usually done in a shop according to the engineer's design's drawing. The steel used in a structural steel framework is made in long pieces called shapes. In cross-section, common shapes look like the letter I, the letter H, the letter T, the black letter U, and the letter L. These long pieces of steel are cut into the lengths by power saws or by heavy shearing machines. Structural steel is often assembled by a subcontractor called a structural steel erector. He employs iron workers to rig, handle, fasten, and clamp and brace the parts of the structural steel. Rigging and handling steel shapes. The columns for the lower levels of a steel frame usually are set in one piece. The beams connecting them are set by using a crane moving on wheels or crawlers. When we have a very tall building or tower to put up, A derrick is used for the higher part of the frame. The derrick is set on a level framework above the ground level. When all the framework that can be reached by the boom at that level is finished, the derrick is taken apart and moved up to rest on the steel that has been set. The derrick has two main parts, a mast and a boom. The mast is a tall pole that is held vertically upright by legs or by guy wires. The boom is another long pole that works like the boom on a crane. It is fastened to the bottom of the mast on a pivot point so that it can move up or down or sideways. A piece of steel shapes or an assembled section is hung from the hook and lifted into place. The steel shapes are hung on the hoisting cable by riggers who know how to safely attach the pieces. The rigging must be done so the piece will be in the correct position so it can be fastened in place. This requires special knowledge about hoisting frames, cables, and ropes, and about hand signals. The hand signals are used to tell the crane operator what to do. Often, the crane operator is out of hearing range, so hand signals are necessary. Setting the supporting steel. Some parts of a steel frame support other parts of the frame. In a building, the columns support the beams. In a tower, the legs support the bracing that ties them together. In a bridge frame, 2 or 3 beams may support all of the other beams or connecting pieces. To set up a steel skeleton, we must first set the bottom pieces of supporting steel. Anchor bolts are used to fasten the structural steel frame to the foundations. Columns for buildings or the legs of towers have a steel plate welded to the bottom of them. This is called a base plate. The base plate has holes drilled in it to match the position of the anchor bolts. To set the supporting pieces of steel, each piece is lifted up the truck with a crane. The base plate on the bottom is then set on the foundation so that the anchor bolts stick up through the holes in it. Base plates must set at the correct height, which may be 1 inch or 2 inch above the foundation concrete. The plates also must be set so they are level. To set a base plate, shims are placed between the bottom of the base plate and the concrete. Shims are small square pieces of steel plate or sheet steel. Each piece may be of a different thickness. A stack of shims is set under each of the 4 corners of the base plate using the thickness needed to set the base plate level and at the correct height. Then steel are drawn down tightly against the base plate to hold it in place on the shims. Yung shims po dito yung parang square dito sa ilalim ng column. Pinapatong po para makuha yung tamang height na 2 inch or 1 inch. Setting the connecting steel. After the supporting members of a structural steel frame are set, the connecting pieces of the frame are placed. All members of the frame, whether partly assembled or not, are delivered to the site by truck or on a bridge construction by barge. To help identify it, each piece had a number mark on it at the steel shop. Using the number shown on the SOP drawing, the foreman of the iron worker select the right piece of section. A crane with a double sling or wire rope with a hook on each end is used to lift the piece. The 2 legs of the sling meet in a steel ring at the center. The hook on the lifting line of the crane is hooked into this ring and the piece is lifted. To guide the piece or section of steel, a length of fiber rope is tied to one end. This is called a tagline. The next is fastening steel shapes. Each iron worker carries a spud wrench, which is stuck into a holder on a leather belt. The spud wrench has jaws on one end that fit around a nut or the head of a bolt. The other end is a handle 12 inch to 18 inch long that tapers down to a rounded point. When one hole in the beam is lined up with the correct hole in the connecting piece, he pushes the point of the wrench handle through the 2 holes. This also lines up the other holes in the connection. The iron worker then takes bolts from a small pouch hanging from his belt and puts them through all the holes of the connections. He puts nuts on the threaded ends of the bolts and pulls the 2 pieces of steel together by turning the nut with the jaws of the spud wrench. An iron worker at the other end of the beam does the same thing at the same time. All connections between parts of a structured steel frame are made in the same way. The bracing pieces between the legs of a tower are connected between the columns of a building. Each piece in the frame or a bridge also is placed in this way. When sections have been assembled in a yard and hauled to the site, one section is connected to one another in this way. After the pieces of sections are fastened together with bolts, they must be riveted, bolted, and welded together permanently. A torque wrench operates something like a very slow electric drill. It turns the nut down hard on the bolt until the two pieces of steel are pressed tightly together. If the frame is to be welded together, welding is done around the edges of the connecting pieces. Plumbing and bracing. Before the final riveting, bolting, and welding can be done, the first part of the frame to be braced must be leveled, plumbed, and then held in position with guy wires. Guy wires are made of steel wire rope. In a building frame, they may be fastened from the bottom of one column to the top of another column. Guy wires also may be fastened from the upper part of a column to a long iron stake driven into the ground some distance away from the column. The columns are plumbed by hanging a plumb bob from a string beside the column. When the face of the column lines up with the string, the column is plumbed. The number or thickness of the shims under the base plate have to be changed to tilt the column until it is plumbed. Erecting concrete frames. Concrete for the frames of superstructure is made in the same way as the concrete used in foundation. The only difference is that stronger concrete is needed. The strength is measured by how heavy a load it can support after it has hardened for 28 days. Concrete used in foundation is strong enough if it can support a weight of 2,000 pounds on each square inch of its surface. The concrete used in frames made by putting more cement into the same quantity of sand and gravel. Concrete columns and walls. Reinforcing steel called dowels are placed in the foundation concrete so that they will stick up where the column is to be built. Around these dowels, the surface of the foundation concrete is left wrapped so that the concrete in the column will bond the concrete in the foundation. The long reinforcing bars that are used in the column are tied to the dowels with wire. The long bars are then held in place with hoops of smaller steel bars the same way that they were in the building of foundation piers. The panels are fastened together with short pieces of wire that are overlapped at the corners and nailed to each other. Panels also may be fastened together with metal bars called column clamps. Sometimes from ties may be used. The forms are plumbed and braced just as the piers forms were. Round columns use curved metal form like those used for piers. Concrete beams. The connecting pieces for a concrete frame may be of any size or shape, but they are called beams. They may connect columns, the two pieces of wall, or a column and a piece of wall. The column or wall forms are built up to the level of the beams, and then the beam forms are built before only concrete is placed. The concrete is placed into the columns and the beams at the same time, so they will be formed together. All of the concrete that was placed for the foundation was supported on a bearing surface or on a footing. Concrete beams are suspended in the air. The forms for the beams and the concrete has hardened and can support itself. Across the top of each shore is nailed or fastened a piece of lumber at the right angles to the line of the beam. This piece of 24 inch to 30 inch longer than the width of the bottom of the beam. It is braced to the shore underneath with diagonal braces. Fabricating the beam form. The form for a concrete beam is aided with a beam bottom and two beam side pieces. These are made of 2-inch thick dimension lumber and they are cut to the necessary width or height. The line of the beam has been marked on top of each 4-inch by 4-inch that rests on the shores. The beam bottom is nailed to the top of each 4-inch by 4-inch along that line. Then the beam sides are nailed to the beam bottom on each side. Each 4-inch by 4-inch will stick out beyond the beam sides about 12-inch or 15-inch. The beam side is then braced to the outside of the 4-inch by 4-inch. After the beam is formed, the reinforcing steel is set. The reinforcing steel bars in beam are called truss bars. The same bar is bent so that the central part of it is close to the bottom of the beam. Toward the ends of the bar bends up on 45 degrees angle so that the ends are near the top of the beam. On the end of each bar, there is a large hook into the steel in the column. These bars may be fastened together with smaller bars like the hoops in a column. Fabricating suspended slab forms. To build a slab form, we will start by placing shores every 4 feet in rows and place a 4 inch by 4 inch on top of each row of shores. The 4 inch by 4 inch is called a stringer. At right angles to the 4 inch by 4 inch, we will place a 2 inch by 4 inch or 2 inch by 6 inch every 16 from one end to the slab to the other. This will be stood on edge and nailed to the stringers. These pieces are called joists. Over the joists, we will nail sheets of plywood to form the facing for the underside of the concrete slab. Where the slab meets the beam. Side is cut down so that the plywood can be nailed to the top of it. The reinforcing steel for the slab is set on the plywood. These are straight bars set of intervals 4 inch, 6 inch, or 8 inch in both directions. The bars are fastened together where they cross. To keep them above the bottom of the concrete slab, they are set on small wire supports called chairs that rest on the plywood surface. Placing the concrete. Concrete is placed in forms for the frame of a structure in much the same way it was placed in the foundation. The concrete is placed in the column forms a short time before the concrete is placed in the forms for the beams and slabs. Concrete shrinks a little as it sets up. We let this shrinkage take place before the other concrete is placed. If the structure is not very high, we may place the concrete by using a crane with a long boom. A concrete bucket is hung from the hook on the lifting cable. For taller structure, we may have to use a hoist. A hoist is like an elevator in a tall building. Finishing concrete frames. Some of the concrete surface in a structural concrete frame may be left exposed when the structure is finished. These surfaces will be finished in the same ways that were described for foundation concrete. The top surfaces of concrete slab will usually be given a smooth, steel trowel finish so that the tile or other flooring can be put over them. Generally, the columns, the underside of concrete slabs, and many of the beams will be covered by other surfacing materials and will not need to be finished by rubbing or troweling. Placing concrete shapes. Some parts of a concrete frame can be made in a manufacturing plant and hauled to the site for erection. These pieces are called precast concrete shapes. They are made of the same kind of concrete, but instead of using wood for the forms, metal is used. Concrete placed in foundations or in concrete frames is cured by wetting or coating it with curing compounds. Precast concrete is cured at the manufacturing plant with steam. Some precast concrete shapes are called pre-stressed concrete. Pre-stressed concrete is not reinforced with reinforcing rods as those used in other kinds of concrete. It uses wires for reinforcing the concrete, like the wires in a violin. These wires are stretched very tightly and then the concrete is formed in the forms around them. Instead of making a concrete slab when the concrete is placed, precast or pre-stressed concrete slabs or planks in 2 feet or 3 feet width can be used. The ends of these planks are supported on the concrete beams. Precast concrete shapes may be beams for highway bridges, slab for steel or concrete frames, or T-beams for roofs or substructure. Building wood frames. Generally, wood frames are used for small buildings such as houses. The frames for these buildings may be subdivided into 3 major parts. The first is for floor framing. Most floor framing is made up of the horizontal members, which are called joists. The next is wall framing. Most wall framing is made up of a vertical member, which are called studs. The last is the roof framing. Most roof framing is made up of a slope member, which are called rafters. The major steps in erecting wood frames at the site are laying out and marking the locations and positions of the framing members according to the blueprint, marking of the lengths of a lumber, sawing the lumber, assembling the parts, and lastly, leveling and plumbing the frames. Setting seals. To secure and hold wood framing to the foundation, an anchor bolt is first set every 5 feet or 6 feet along the center of the footing or wall. To begin construction of the frame, a seal is laid on top of the foundation. The seal is a horizontal piece of lumber and is the bottom piece of the frame. Holes are marked and drilled into the seal so that the seal can drop down over the anchor boards. A thin layer of grout, which is a mixture of sand, Cement and water may be placed under the seal to help level it. After the seal is leveled, it is held in place by tightening nuts down on the threads of the anchor bolts. Assembling joists. Joists are planks set on edge. They are placed to give a base on which the flooring materials can rest. Joists rest on seals and extend from one foundation wall to the foundation wall on the other side. Assembling girders. When the distance between two foundation walls is great, a girder may be used to support the joist. A girder is stronger than the joist used in a frame.
Laying subflooring. A subfloor is nailed to the top of the joist because a second is always placed on top of it. This floor is called the rough flooring or subflooring. Boards or pieces of plywoods are used for the subflooring. The boards have tongues and groove of the next boards. This keeps the boards from twisting and makes a tighter floor. Yun lamang po yung report ko at maraming salamat po sa pakikinig.